In this section, we'll be learning about the AF formula data reference. Now returning to our HVAC example, let's say that our HVAC maintenance people have come to us and they're going to be doing some analysis on the control system performance. And basically they're looking at a trend like this where they have the inside temperature of a zone and the thermostat setting for a zone, and they're interested in seeing how closely the temperature is tracking this set point. So one piece of data that they're interested in is the differential between the temperature and the thermostat set point. And of course, they could pull all the archive values for these two attributes into DataLink and calculate the differentials on their own. But it'd be nice if we could just put that into AF and then they could access it on the fly. So with the formula data reference, we can do a simple calculation like that and display it through AF. So let's see how we do that. First, we're going to create a new attribute, and I'll call this temperature offset. That's going to be indoor temp offset from set point. Now for the UOM, this one's a bit tricky, but since we're taking the difference of two temperatures, the unit of measurement we want to use is this temperature delta. That's going to ensure that any unit calculations done between temperature differentials are correct. Next, we'll go to our data reference and select formula. And we'll go back to our settings dialog, and we see the formula configuration GUI. And the first thing we need to do is define our parameters, or our variables for the calculation. And I usually like to choose a variable letter that somewhat corresponds to the actual attribute name. So I'll use S for the thermostat set point. And I also usually like to explicitly define the units of measure, though it's not really necessary. Next, we want to get our indoor temperature. I'll just call that T. And now that we have our variables, we can state our equation. Now, if you want to see what the possibilities are for the type of equations we can form, you can click on this little arrow to the right, and of course this is the list of all the variables that we have that we've defined. Here are the possible operators, your typical mathematical operators. You can see that there's some if, then, else, and or type statements in there for writing logical statements. And finally, there's all the different mathematical functions that we have available. So not quite as expansive as the performance equation syntax that you may have seen used in other areas of Pi, but still quite a few options here. So I'm just going to go and type in my equation by hand. So we just want the difference, so it's S minus T. Result UOM will be in degrees F. I can do an evaluation to test it. Looks like it's doing all right. And so now we have our temperature offset. So if I jump back to my process book display, I could go into build mode and I can add that new attribute to my display if I want. Looks like process book has not picked this up yet. Oh, of course I need to check this change in. There we go. Now if I go and add my attribute, there we have it. Temperature offset, degree Fahrenheit is fine. I'll show the unit, let's hit OK. Let's see, I'll make this a little easier to see. And our temperature differential is readily available and calculated on the fly whenever a user needs to access it.